Uh, Hello, everybody. I got an idea. Tomorrow I'm going to have a table at one of the farmers markets in my area, and I am getting ready to present all of my printed items for people to buy. Cool little widgets, a couple bigger objects, but I need to list the prices. And rather than just like taking a paper and folding it in half and writing the price on it, I want to design a system so that I may swap out any numbers that I want and then just print my prices, because that's what I do. And so here we go. Think this one's right. Yeah, there we go. So this is Fusion 360, my modeling program of choice, and I'm just going to get right into it. I've already put my parameters into the parameters of what I think a good size for this little... Whoa, sticker just fell off. I'm calling the stand a stand, and then I'm calling little pieces chips. And so I guess having a sketch is what I'm about to do to describe what the idea is, but a 90-degree, or rather 45, 45, 90 triangle probably, with a little inset dovetail idea, and the chips are going to slide in from the sides and then just sit on the flush level of the hypotenuse. So I'll go. If you have any questions, then just type them in chat. You know, I do not need to make the sketch on this side. I need the profile to be on this side. There we go. And I'm going to model it so the letters sit flat on top. And so that's probably not going to be print orientation, but I want that to be my frame of reference, the actual front. I will probably have some 45-degree angled planes that I model off of at some point, but maybe not. So the idea no, undo that. The idea. Basically this shape. And then the chip will fit into this channel. It'll slide right in. And I'll probably shave off this corner to make the chip be able to print flat. So let's make these collinear and also make them collinear with the origin. If I can do that. I don't want them to be coincident. Okay, never mind. And want these two to be not parallel, equal. These two to be equal. And these two to be equal. That might be over constrained. Now the size, I want this. No. Want dimension, there we go. These 2 points to be not the chip stand. I don't have a stand face length parameter. Chip face length, let's just do +5 for now. Yeah, that's gonna mess it up. I want to make a parameter stand face length, I guess. It will be chip face length plus actually, you know what? That's not where I want to measure it. I want to measure it from the inside points because that is how it relates to the chips. So undo that. Want to dimension these two together, not that way. Stop. Nope. The point. Yeah. And that will be chip face length plus tolerance on both sides. And these should be equal. These are not. Oh, there we go. And the dimension that I have chip thickness. Wait, stand thickness. Okay, so this, between this, will be stand thickness. And that should constrain these two already. Just have to determine how deep I want the chip. So the chip thickness, right now it's based on stand thickness, but I think that's okay. The chip thickness will be from here to the other side, directly through. So let's make a construction line, like so, like that. And this construction line is what I dimension chip thickness. And I want to add tolerance. That still hasn't constrained it laterally. If I say, can I make a midpoint of these two? No. I want this, I want them to be equidistant. So maybe I just make a line here and then say the midpoint is center. Now these are all of the lines have turned white, and that allows, or that tells me that they're constrained. So this is the stand shape. I feel like I want to chop off these corners. Chamfer them. Is there a chamfer in sketch mode? There's a fillet. Ah, yes. Stand thickness. Let's not do that on sketch layer. Let's do that afterward on the body step. So that is constrained. That is the stand. Save. The chip. The chip also needs to be on this side too. Oh, delete that and make a new sketch. This is going to be chip. And it's going to be a line. Gotta look at... Oh, I haven't saved this yet. I need to save this. And make something not editable. Okay, hold on while I save. Okay, there we go. So the chip is going to have this shape. Do I have a chip angle? Yes. But that doesn't need to exist. Although, so I was imagining that parameter to be the viewing angle, so I could, for instance, change the length of this line, this edge. So, like if I set that version to 0, that parameter, then this would sit flat, which would break a whole bunch of things, but it would allow me to tilt it. And I think if I'm just going with 45 degrees anyway, I'm going to co-opt that parameter and just use it here. The angle between these two dimension is chip angle. That is not what I wanted. Chip angle. Okay. I need to be 180 minus the chip angle. There we go. Because this is an obtuse triangle right there. So now I want these two edges to be equal. Wait, no, not equal. This edge to have the midpoint in the center. These two, looks like it has perpendicular. Yep, let's do the same here, perpendicular. And these are parallel, good. And these I also want to be equal. And these I want to be equal. So what's the issue? The depth. So these two make the dimension of chip thickness. And what's the issue here? Oh, got it. Chip face length is, I think, what I called it. Yep, now it's constrained. And that's the profile, I think. It's a fairly simple idea, but using these two shapes, I can keep the chips in place. So now let's save first. And extrude. So extrude that this way, chip length. And so this kind of diamond prism, I guess it's a hexagonal prism. Yeah, stretched hexagon. That's going to be what the chip looks like. And then extrude the stand length. So we'll end up with a stand like so, which you place down, and then you slide in the chips from the edges. And let's open the bodies. This one is chip. This one is stand. And I think that's it. That is enough that I can make a test print I'll probably slice it up. Let's do that. So the test prints that I tend to do involve making sketches and then let's rename this. Then extruding the sketch. This direction, say 5 millimeters, and intersect as the operation. That way I only get a tiny slice, but my original models stay at their correct size. And so this way I can print both models. And that tolerance, right now, it shows that the chip is pushed up against the front, but it'll settle. And I will probably add the numbers or letters or whatever I want to print on the chip in the slicing step. So let's save that. Yep. Actually, before that step, let's reverse. I want to chamfer some of these edges. Uh, 1 millimeter? Is that what I usually do? Maybe 2. Stand edge chamfer. Let's do that as stand thickness. Maybe almost 2 times, 1.5 times. Okay, first chamfer operation. Let's cut these corners. Yep. Huh. That doesn't make a 45-degree angle, but I'm okay with that because in this current orientation, the print bed is on the top, and that is a steep enough angle that it should be fine. So let's save that, and I can modify it later. Then let's chamfer everything else on the stand. So hide the chip. This and this. And it gets all the edges there. I like that. I also want to get these edges. I'm not sure if I want to get this inside edge, if it'll cut off too much. That should be fine. So that means I can just select, well, everything. Select it all. Chamfer everything. It makes it nice and organic, but keeps the edges good. And let's check the angles again. So this angle right here might be too much, because compared to this angle right here, it's 146 degrees. What is that? Wait, is that 45? That might be okay. But if I need to, I can remove that specific chamfer just to make that angle better. this should be. I want to see the angle between them. Come on. They should intersect there. So that should be good operation. Let's also chamfer the chip. Everywhere. All of the chip. Select all. Everything. Whoa. Chamfer. Yeah, it's just going to be this little gem. This reminds me of my to-do list gems. It's the same shape. But I had to model in a clip on the back end. This one should just be a good gem. Again, I worry about this angle, perhaps, because that is... that might be hidden. Oh, it definitely won't be. Yeah, I worry about that angle. Because print orientation... Oh wait, in this case, print orientation, or the print bed of all the chips will be the back, so I can print the chip in one color and then print any text on top in a different color. So then this overhang won't matter. And I'd rather have it, even if it's a little ugly, so that this arc doesn't interfere with the back edge. And yes, I'm expecting there to be a bunch of space in the back behind the chips, but I'm okay with that because I still need the entire assembly to be able to sit flat on a table, and that this large flat area will work. So let's save. And export. Oh wait, let's move forward in time. So you see this makes a slice, but the models themselves are largely unchanged. But it allows me to... Let's export. Alphabet stand. Hold tight while I export. This is the chip. And I want to... Wait, no. Export wasn't what I wanted. Save as mesh, that's what I wanted. In 3MF. And save it to... projects. And now let's export the stand. And open up my slicer. So I like using Prusa Slicer, and it has a preset for my Voron 2.4, which is very nice. It shows an actual bed with the screw cutouts, and I have a 300 millimeter by 300 millimeter bed. So let's import the models that we just made. The chip didn't come with it. There we go. So this is technically symmetrical, but both of them are upside down based on the way I modeled it. So let's rotate these by 180 degrees. It drops it back down to the bed. So this is how they will actually print. And let's make some tests. I want to move it a little bit closer together. And this is to allow me an opportunity to see if the fit is good, if I gave enough tolerance around the edge, but also if it stays. And oh, I don't have a camera to show you guys, but I'm gonna go through the motions to slice this and start the print. And for this test, I could print this model on the bed like so, but I don't think that would be an accurate test because it wouldn't be printing in that orientation later. I would want to print the whole stand basically face down, whereas the chip is... Oh, the chip would technically be face up. I didn't have to rotate that one. In fact, let's rotate it back. For test integrity, 180 degrees. So I guess let's put something on top of here. I do have a... Wait, I don't want to import that. I want this to have a modifier. And that would be under 3D printing. Where is my logo? Not under the testing. There we go. The logo with cuts. So this is a cool little logo that I designed. And I doubt it will show up at this scale. But I can still put it there as an example. Ooh, maybe let's stretch it so it's comically long. Yeah! Okay, not how it'll end up in the end, but good enough for a test. Yep, it shows through. And this shows it'll take just over 30 or approximately 30 minutes. And I do want to add a brim. I really should add mouse ears instead, but this is just a test anyway. Yeah, this brim allows the bed adhesion to be high, but it's only on that lower level, so it prints afterward. This does introduce post-processing, but for this test, I'll just break it off. Should be pretty simple. I usually print with 3 walls and 15% infill, cubic infill. You can't really see the pattern at this scale, but that's how it be. And for this test, this shape is pretty rickety. It's not the strongest, but again, at full scale, this will be long bars. And they will eventually have to meet up in the center, which is not the best way that you usually want to print things, but I do trust my Voron printer. It's pretty reliable. And this allows the layer lines to be aligned so they won't interfere with sliding the chips into place. Because if I print it in another orientation, the layer lines might act as ridges. But this looks good to me. This looks like a job for me. Alphabet stand test. And I have Clipper on my Voron printer, and I'm running Mainsail as the interface. My printer's name is Voxel, by the way. So here's the preheat event macro. I did not set a macro to preheat it. I should do that. That would be really easy. But I print PLA with a heated bed at 60 degrees, and then my extruder in the 200 area, but I preheat to 180 because that softens it enough that I can change the filament if I need. So I am going to go change the filament, and then we can get this uploaded. Filament is loaded, so let's start this print. To print. The, what did I call it? Alphabet stand, first one in line. I print PLA at 215 degrees. That might be a bit high, but that's the value that has been working for me at the speed that I usually print. So the print will climb in temperature and then go through home procedure and quad bed mesh leveling. What's it called? Usually it's on here somewhere. But yeah, it has a inductive probe so that it can test the aluminum bed at all of the probe locations, and tram. The motion system, if necessary, does that automatically, but I'm going to go watch the first layer. That is a good rule of thumb. Make sure there's no filament getting in places it's not, and make sure it is getting in places it should. So I'm going to go head over there. You can watch this interface for now. It's already done with the first layer, and this is a relatively small footprint part, and so I will get to see if the scale is correct. It fits big enough for the display that I want visibility. And ooh, I forgot to do anything like a layer change, but yeah, I have a layer change macro, so I can put it on this layer and change the filament change. So the letters or numbers on top of the chips are a different filament entirely. I don't think that's necessary in this case, because I would be printing the stand separate from all of the different chips, so it doesn't need to interact in this case. So right now I have my test filament loaded. It's just a semi-transparent kind of tinted filament. It's called Rose Gold by Atomic Filaments, and I got it as a transition spool, and that is by far the most volume of all of the spools that I received, and it prints a bit too transparent for my normal use cases, so I just use it as my junk filament. It's kind of pretty, but it's just a little bit too transparent without actually intending to be transparent. It's supposed to be shiny and rose and gold, but it just kind of is pink and semi-transparent. But it makes like the quality itself of the filament is very good, so makes good test. There's not much more to show you in a stream of this type, because again, I don't have a webcam, and this just needs to finish printing. What did it say, 30 minutes? Yeah, I'm not going to make you sit through 30 minutes of not being able to see the printer. I would love to do some like live 3D printing webcam streams if anybody's interested, but as it is, that was basically start to finish a workflow of me designing a part. I already had a good idea, and I have a sketchbook that I have kind of planned out my measurements, and it has a couple of different views, like front view, side view, to see how the various pieces would interact. And so I've already planned that in my head. I do most of my engineering planning in my head before I even sit down to model. But here, let's rewind. I could maybe do a render. To do a render, I would have to twist this, both of them, so they would sit flat on the ground. But let's do it. I want to roll history marker. No, delete everything after this. I thought there was a way to do that. Delete features after history marker. Yep. Okay, so now this is the present, and I want to rotate these two. There is a tool for that. It's the move tool. Rotate 45 degrees. Very nice. And I guess let's move the chip as well this way so you can see it in place. And that's actually how you will add new chips in from the side. They should slide right in. And I don't do renders very often. How should I do that? Rotate for render. Render. Oh, I should probably change the materials. I like using glass so I can see all the edges. The stand, let's... Whoa. There we go. Let's make it a plastic. Let's make it a blue plastic. Let's make this a red plastic. And let's put texture map. No. How do I change the background? The scene. Environment. Yeah. Try lake bed. Do I not have it downloaded? I've used this before. Oh, current environment. It just doesn't show up until I render. Let's do 1920 by 1080. Well, it doesn't need to be that big. Let's do 720. Local render. Let's just do a standard render just so I can see it. Does the dry lake bed not show up? Maybe I was mistaken. Where is it supposed to be? Yeah, let's get the corner view. A little bit down. Yeah, that's not quite what I wanted. That is a render. You are correct, Fusion 360. But I want a background. Yeah, I'm supposed to be able to see the sky. What gives? Oop. Hmm. Yeah, I want to use the dry lake bed. I like the dry lake bed. Gimme. Why does it not show? Video? Oops, I did not need to make a video. Oh, it was just in the video preset. Got it. There's no other options here. That is a render. Trash. Delete. Get out of here. How do I want to render this so it looks cool, but the background, I don't know how to get the background to work. So I'm doing some Google. :D. It's a classic. In the scene settings, set the background to environment. Aha, it's solid color. There we go. Ta-da! Let's render that. That's what I'm talking about. I'm closing tabs. That was a video played the first second. That was not me saying kiss. Very nice. Cool. I'm going to post that on my Discord. You all should join my Discord. I think it's in my bio. It's definitely on my YouTube side. Discord, I'm howling at the moon. I am reading the comments. You sent an AO what's this, and that's it. Is that not right? Yeah. Yeah, it shows it on stream. Oh, hey. Hello. Thank you, Discord, for streamer mode. Let's go to the den. Let's go to the other projects. Oh, wait. How? Wait, where's this saved? Let's save it in temp. A nameplate stand. I'm going to use it to display prices. Whoa, my internet is not the best. That is a lot of... Wait, no. Oh, it updated. Okay. It only sent out 2 notifications, but it updated the display, the preview. Whew. Yeah, colon D. I said that. I tried to do it back, but it's not letting me use the chat here. I have to sign in first, I think. Wii U. Yeah. It's making me log into Twitch, and I don't want to do that right now. Which is weird, because I'm using Streamlabs to stream to Twitch, so the chat should be connected, but whatever. Can I zoom in? Zoom. So that is the project. That is the alphabet stand. That's what I called it. Let me go check the actual print real quick. 1 sec. It's looking okay. I've been having some trouble with layer shifts recently, but uh, I think I have to dial in my fan cooling better because right now with the tiny slice that I'm printing, it's having some trouble with these overhangs because it's not cooling fast enough. That's equivalent to the smokestack on the 3D Benchy. And that might cause a trouble with this test, but we'll see. Oh, yeah. So this right at the bottom of the chip, that is another thing that I mentioned I was worried about. Might be okay, and it's hidden in the back, but I could possibly fix that. I'm mostly worried about these in my test print. But I think that's the stream. That's all I wanted to stream that I was doing. That was cool. If you're interested in my process, leave a comment, ask me some questions. But as of now, let's go to raid somebody. Yeah, there we go. Who do we want to raid? Jenny's playing Minecraft. Ooh, I have been introduced to Jitspo, who is a game developer. He's making something in Godot. I'm not entirely sure what it is. Am I playing my own stream? Or is he not muted? Why is that?
Do I have an okay lab dev?
Yeah. I can't mute him. This is weird. Anyway, let's go over there. Stream or raid. Let's raid this dude. Where is my stream dashboard? I think it's called. How do I get to my creator dashboard?
Let's see.
Let's do the A-Raid stream manager. That should give me all of the buttons that I want. Raid channel. Jitspo. Start. Wow, woo wee wah. Thanks everybody for watching. I will probably share some pictures from the farmers market, and using this model, I'll slice some more chips with some numbers and letters on top, and afterward assemble them all into prices. So, but that's happening tomorrow morning, so I better get printing. Thanks for watching.
Why does Alt back arrow not go back? Come on, Visual Studio. Old versions of Visual Studio did that. Setafire. Hey. Thank you for the raid. Hope you had a good stream. Done with the 3D modeling, huh? Nice. It's all completed. No more 3D models. Every model is made. Or just for tonight. Oh, thank goodness. Now we just need to move on to UV unwrapping, right? And then texturing and animating, rigging. Probably should do the rigging before the animation. I need to have a variable name here. Color lab. There we go. That's useful. Can't just assign that to the type. Okay, so now we've got this. Got a test print on the way? Oh, so you don't need to worry about UV unwrapping and stuff. You're just 3D printing. Nice. Let's see. Okay. I guess we have color 1, color 2, and then we go and so we're going to do ldiff equals color 1.l minus color 2.l. These need to be signed. Because that could be a negative number. All right, and then return ldiff times ldiff plus adiff times adiff plus bdiff times bdiff